A line of dry yellow grass runs beside an unpaved road in late afternoon. There is a low fence of rusted wire, a patch of grey gravel where two tracks meet, and a row of stringy bark eucalyptus trees standing straight against a flat horizon. Nothing moves except the dust lifted by a passing utility vehicle. Beneath that surface sits a concealed landscape of extraordinary violence. What is striking is not merely that these geographic hazards exist, but that for generations they remained unrecorded on official public survey maps, treated as ordinary ground by those who walked across them daily. How does an entire continent conceal some of its most lethal geographic traps in plain view? Later, we will examine an underground fire in New South Wales that has burned unchecked for over 5,000 years, and a river system in Western Tasmania where industrial drainage stripped 40 square kilometres of rainforest down to bare rock. For decades, colonial surveyors mapped Australia under the assumption that interior hazards were purely matters of distance and aridity. It was a reasonable assumption for the 19th century, when charts documented only what a chain and compass could reach. The reality is far more intricate, shaped by hidden hydraulic pressures, unstable rock strata, and toxic legacies in the soil. 22. Josephine Falls, Queensland. The creek flows from the granite foothills of Mount Bartle Frere through tropical rainforest, dropping over smooth stone ledges into clear emerald pools. To visitors on the walking trail in Wooroonuran National Park, it appears as a tranquil swimming hole. The danger lies in the mountain catchment above. Mount Bartle Frere rises 1,622 metres, receiving more than 8 metres of rainfall annually. A sudden summit downpour, invisible and unheard from the picnic grounds below, channels millions of litres of water down the narrow gorge in minutes. The creek level surges by 2 metres without warning, turning calm water into a violent torrent. Submerged boulder sieves and granite ledges pin swimmers underwater against the full force of the flow. The Queensland Parks and Wildlife Service has recorded multiple drownings and dozens of emergency rescues here, prompting automated flash flood warning systems. 21. The Gap, Sydney, New South Wales. The sheer sandstone cliff on the South Head Peninsula drops 47 metres vertically into the Tasman Sea, framing the southern entrance to Sydney Harbour. From the clifftop platforms, the ocean appears completely flat. The geological structure of the Hawkesbury sandstone is the trap. The cliffs are cut by horizontal bedding planes and vertical joint fissures, continually undermined by ocean swell compressing air inside sea caves below. Large tabular slabs of sandstone break away from the cliff face without warning. Along the platform base, long-period ocean swells travel across the Tasman, sweeping over the lower benches in sudden 3-metre surges that pull anglers and walkers off the rock shelf. 20. Mount Lyell and the Queen River, Queenstown, Tasmania. The gravel hills around Queenstown stand bare, stripped of soil and vegetation in a stark orange moonscape. Beginning in 1896, the Mount Lyell Mining and Railway Company operated 11 copper smelters in the valley, releasing sulfur dioxide fumes that produced concentrated acid rain. The acid stripped the surrounding temperate rainforest down to bedrock across 3,000 hectares. Simultaneously, over 100 million tons of mine tailings and slag were dumped directly into the Queen and King River systems. The water remains acidic, carrying heavy metals into Macquarie Harbour. Today, the bare gravel slopes remain prone to sudden debris flows during winter storms, while the riverbed is permanently choked with metal-rich sediment. 19. Devil's Pool at Babinda Boulders, Queensland. In the foothills south of Cairns, Babinda Creek cuts through crystalline granite, carving polished chutes and deep basins. The traditional owners of the country, the Yidinji people, have long held cultural knowledge regarding the hazards of these waters. Beneath Devil's Pool, the water flow is forced through narrow subsurface fissures known to hydrologists as siphon traps. The volume of water moving through these restrictions creates a vacuum that pulls swimmers beneath submerged granite ledges into flooded caves where divers cannot safely enter. More than 20 people have drowned in this pool since the 1950s. The calm surface conceals a downward hydraulic draw exceeding several tons of force. 18. The Rip, Port Phillip Heads, Victoria. The entrance to Port Phillip is a marine gorge less than 3 kilometres wide, separating Point Lonsdale from Point Nepean. Beneath the shipping channel lies a sharp underwater limestone plateau, where depth drops abruptly from 30 metres to less than 10 metres over an uneven reef. When the tidal exchange forces the bay's volume through this gap against incoming Southern Ocean swells, it generates standing waves up to 10 metres high and tidal currents exceeding 8 knots. Early maritime charts recorded dozens of shipwrecks along the reef, and it remains one of the most hydrodynamically violent navigable passages in the world. 17. The underground fire of Mount Wingan, New South Wales. In the upper Hunter Valley near Wingan, a plume of sulphurous smoke rises continuously from a fractured hillside of Permian sandstone. Settlers in 1828 assumed the vent was a volcano, naming it Burning Mountain. The geological reality, identified by the Reverend Peter Nicol Miller in 1829 and confirmed by the Geological Survey of New South Wales, is a subterranean coal seam burning 30 meters underground. It is the oldest known naturally burning coal fire on Earth, ignited at least 5,500 years ago. The combustion front moves southward by roughly 1 meter each year along the Greta coal seam. Temperatures exceeding 1,000 degrees Celsius bake the overlying mudstone into brittle clinker, collapsing the ground into sinkholes and vents, emitting carbon monoxide and sulfur dioxide. 16. Mount Gambier sinkholes, South Australia. Across the limestone coast, the ground consists of porous tertiary Gambier limestone deposited between 30 and 15 million years ago beneath the Otway Basin. Millennia of groundwater movement dissolved the calcium carbonate, carving submerged caverns beneath thin surface crusts. Sinkholes such as Engelbrecht Cave and Little Blue Lake sit directly beneath suburban roads and farmland. In several locations, heavy traffic operates on ground where the limestone ceiling is less than 2 meters thick. Dive teams from the Cave Divers Association of Australia have mapped kilometers of flooded passages, but catastrophic collapse remains an active risk where changes in subterranean water pressure weaken the fragile rock ceilings. 15. The boulder fields of Black Mountain, Kalkajaka National Park, Queensland. Rising suddenly out of the savannah 25 kilometers south of Cooktown stands a mass of unweathered granite boulders stacked across hundreds of meters of elevation. Kalkajaka, known to the eastern Kuku Yalanji people, formed 250 million years ago as magma cooled deep within the crust before erosion removed the softer overlying stone. The dark color comes from a microscopic coating of iron and manganese oxide and algae on the exposed granite. Inside the mountain lies an unstable labyrinth of air-filled voids and vertical drop-offs. Sudden boulder shifts caused by thermal expansion during heat waves create shifting chasms where people and livestock have disappeared, trapped in underground chambers beyond rescue reach. 14. The silting of Lake Eyre and the Cooper Creek floodplains, South Australia. Cathy-Thander Lake Eyre sits 15 meters below sea level, draining a closed endorheic basin of 1.2 million square kilometers. For years at a time, the lake bed is a vast expanse of dry salt crust covering saturated mud. When monsoonal rains in Queensland fill the Diamantina and Cooper river systems, millions of gigalitres of water flow through the channel country into the lake. The hazard is deceptive topography. The salt crust measures up to 50 centimeters thick, appearing solid enough for vehicles. Beneath lies uncompacted gypseous clay. When the crust breaks, heavy vehicles sink into corrosive mud, stranding travelers where surface temperatures exceed 50 degrees Celsius and water does not exist. 13. The quicksand of the Fitzroy River estuary, Western Australia. Near Derby in the southern Kimberley, the Fitzroy River empties into King Sound, an embayment with a tidal range exceeding 11 meters. As the tide recedes, it exposes square kilometers of mudflats composed of fine-grained quaternary alluvium. Under high pore water pressure, this sediment liquefies into non-Newtonian quicksand. Stepping onto the exposed flat breaks the sheer strength of the silt, causing a person to sink instantly. The returning tide advances as a high-speed tidal bore across the delta, covering kilometers of ground in minutes. What looks like an accessible mudflat becomes a marine trap long before surface surveys can map the shifting channels. How did early survey teams miss these violent changes in the ground beneath them? 12. Horizontal falls in Talbot Bay, Western Australia. In the Buccaneer Archipelago, two narrow gorges cut through the red sandstone ridges of the McClarty Range. The seaward gap measures 20 meters across. The second narrows to 10 meters. When spring tides rise and fall by up to 10 meters every 6 hours, water builds up faster on one side of the ridge than the gaps can discharge. This creates a hydrostatic head differential of up to 4 meters between the sides of the sandstone wall. The result is a pair of intense horizontal waterfalls and violent whirlpools. Hydrodynamic modelling by the Western Australian Department of Biodiversity, Conservation and Attractions demonstrates that current velocities exceed 30 kilometers per hour through the second gap, generating downwelling forces capable of swamping powered boats. 11. The salt lakes of the Nullarbor Plain, Western Australia and South Australia. Stretching across 200,000 square kilometres, the Nullarbor is the largest continuous piece of exposed karst limestone on Earth. While the surface is flat and dry, satellite imagery and aeromagnetic surveys by Geoscience Australia reveal a vast network of subterranean collapse features and flooded caves. Sites like Cocklebiddy Cave and Cunalda Cave contain deep, hypersaline lakes sitting in darkness. The danger lies in the unstable limestone crust. With no surface drainage, torrential downpours from decaying cyclones dissolve the subsurface calcarenite limestone from within, causing sudden crown hole collapses where tracks drop into water-filled voids. 10. Captain's Flat mine workings and the Molonglo River, New South Wales. 50 kilometres southeast of Canberra, Captain's Flat sits on massive volcanic-hosted sulfide deposits discovered in 1882. Miners extracted lead, zinc, copper, and iron pyrites from deep shafts along the Molonglo River. In 1939 and 1942, waste dump failures sent thousands of tons of heavy metal tailings into the river. Geochemical sediment cores analysed by CSIRO and the Australian National University demonstrated that zinc and sulfate contamination travelled downstream into Lake Burley-Griffin. The underground workings remain a hidden labyrinth where rising groundwater oxidises pyrites, generating acidic mine drainage that dissolves rock strata and threatens structural collapses along the riverbank. 9. Gun Barrel Highway and the Gibson Desert Sand Dunes, Western Australia. Surveyed by Len Bedell in the late 1950s for the Woomera Rocket Range program, the Gun Barrel Highway traverses 1,400 kilometres of remote desert. The region is covered by longitudinal dunes formed during Pleistocene glacial arid periods. The hazard extends beyond isolation. Ground-penetrating radar shows that beneath loose dunes lie brittle silcrete duricrusts and hidden gypsum claypans. During sudden downpours, water collects beneath the sand over impermeable hardpan, creating subterranean saturated layers known as waterlogged bulldust pockets. A vehicle breaking through the dry crust sinks into subsurface slurry hundreds of kilometers from communication lines. 8. Point Nepean Quarantine Anchorage and Ticonderoga Bay, Victoria. At the tip of the Mornington Peninsula, Ticonderoga Bay appears as a sheltered cove. In 1852, the immigrant clipper Ticonderoga arrived carrying severe typhus, prompting the establishment of the Point Nepean Quarantine Station. Beneath the coastal dunes lie unmarked mass burial trenches cut into fragile calcified sand. Coastal erosion surveys by the Geological Survey of Victoria show that long-term wave action is undermining these bluffs. Unconsolidated sand cliffs frequently collapse onto the beach, exposing historic remnants and creating a severe entrapment hazard. As survey methods evolve, how do modern instruments expose the man-made toxins still buried across the continent? 7. Rum Jungle Uranium Mine, Northern Territory. Located 100 kilometers south of Darwin near Batchelor, Rum Jungle produced uranium and copper for British and American nuclear programs between 1954 and 1971. When mining ceased, 33 million tons of sulfidic waste rock and tailings were left exposed to monsoonal rains. The water saturated the dumps, generating an estimated 130,000 tons of sulfuric acid through pyrite oxidation. For decades, acidic runoff carried copper, nickel, zinc, and radium into the Finniss River, destroying aquatic ecosystems across 10 kilometers of channel. While initial containment cost $16 million in the 1980s, long-term monitoring by the Northern Territory government confirmed ongoing oxidation, necessitating a $300 million rehabilitation program to relocate waste into flooded open pits. 6. The abandoned shafts of Bendigo and Ballarat, Victoria. The Victorian gold rush of the 1850s honeycombed the underlying Ordovician sandstone and shale with thousands of shafts and drives. In Bendigo, mining followed saddle reefs to depths exceeding 1,400 meters, leaving over 5,000 kilometers of underground tunnels beneath the city centre. When dewatering pumps stopped, groundwater naturally refilled the void network. Today, rising water in the abandoned workings dissolves arsenic and sulfides from the walls, producing contaminated water held under hydraulic pressure beneath residential houses. Ground settlement and sudden crown hole collapses still occur as timber supports rot, requiring monitoring by the Victorian Department of Energy, Environment and Climate Action. 5. Hunter Valley Alluvial Cracks, New South Wales. In the agricultural lowlands along the Hunter River, extensive underground longwall coal mining operates beneath prime alluvial soils and river channels. When panels extract coal seams up to 6 meters thick, the overlying sandstone and alluvium collapse into the void. This subsidence creates surface tension cracks up to 2 meters wide across paddocks and creek beds. Geological assessments documented by the New South Wales Independent Planning Commission show that river flow can drain directly into bedrock fractures, lowering the alluvial water table vital for viticulture and farming. Mining operators inject bentonite grout and compacted clay into deep ground fissures annually to prevent creek beds from draining into the workings below. 4. Emu Field Nuclear Test Sites, South Australia. Situated in remote red dune country on the edge of the Great Victoria Desert, Emu Field was used in 1953 for Operation Totem. Two atomic devices, Totem 1 and Totem 2, were detonated on low steel towers with yields of 9 and 8 kilotons. The low burst height sucked sand into the fireball, fusing silica into radioactive glass and dispersing the black mist cloud across traditional lands of the Anangu Pitjantjatjara, Yankunytjatjara. Soil sampling by the Australian Radiation Protection and Nuclear Safety Agency confirmed the presence of plutonium-239 and americium-241 bound in the top 5 centimeters of crust. Entry to ground zero remains restricted under strict radiation protocols. Which site, then, represents the most absolute geographic deletion on the continent? 3. Maralinga Forward Area and the Taranaki Pit Craters, South Australia. Between 1956 and 1963, the British government conducted atomic testing and minor trials within the Woomera Prohibited Area, culminating in the Vixen experiments at Taranaki. The minor trials burned and dispersed 22 kilograms of plutonium-239 using conventional explosives, scattering toxic particles over hundreds of square kilometers. During the 1990s cleanup, the Australian government undertook in situ vitrification and deep trench burials beneath clean fill. Radiation mapping by the Australian Radiation Protection and Nuclear Safety Agency confirmed that while the surface can be visited under controlled conditions, long-lived alpha-emitting isotopes remain locked within the soil profile, requiring permanent residential exclusion. 2. The Blue Asbestos Gorge at Wittenoom, Western Australia. In the Hamersley Range of the Pilbara, the Brockman Iron Formation holds rich seams of crocidolite, or blue asbestos. Between 1943 and 1966, Australian blue asbestos mined over 160,000 tonnes of fibre out of Wittenoom and Colonial gorges. Over 3 million tonnes of toxic tailings were dumped across the gorge floor and spread throughout the town as road base, garden topsoil, and schoolyard fill. Inhaling a single needle of crocidolite fibre can cause fatal mesothelioma decades later. Because monsoonal floods periodically wash tailings out of the gorges across the Fortescue River floodplain, the Government of Western Australia passed the Wittenoom Closure Act in 2022, formally de-gazetting the town, acquiring private properties, demolishing buildings, and removing road signs to physically erase the settlement from official maps. 1. The Meckering Scarp and Intraplate Seismic Faulting, Western Australia. Australia has long been described in geological literature as a stable continental shield, free from active plate margin hazards. On October 14, 1968, that assumption fractured along the southwest seismic zone. A magnitude 6.5 earthquake struck the wheatbelt town of Meckering, rupturing the surface along a 37-kilometre-long fault scarp with a vertical displacement of up to 2 metres. Geoscience Australia monitoring proved that intense horizontal compressive stress, generated as the Indo-Australian plate moves northeastward toward the Indonesian arc at 7 centimetres per year, builds up inside ancient Archean crust until the brittle rock shears. It was the moment Australian geologists recognised that the continent's interior is not inactive, but a loaded tectonic spring. What kept these hazards invisible for so long was never an absence of evidence, but the colonial assumption that an ancient landscape is necessarily an inert one. Detailed seismic networks, satellite interferometry, and deep core drilling continue to track subsurface stresses across the continent, though thousands of legacy mining voids remain unrecorded on official cadastral databases. The map appears clean, surveyed, and settled, but the ground beneath it continues to move, collapse, and react in deep time. Which unexpected landform or geological anomaly in your own state or territory has always seemed out of place to you? Share your observations below and subscribe to follow our investigations into the hidden geography of this continent.